This is the unit circle that we learned about earlier this year. As we can see here, the unit circle has these four main radians, which is going to be 2 pi, pi, pi over 2, and 3 pi over 2. The radian of a circle is 1 pi, or in the circle 180 degrees is 1 pi. So this is where the radians come in and represent these angles in forms of pi, such as pi over 4 or 7 pi over 6. And as you can see, for example, in 7 pi over 6, it's represented by the angle of 210 degrees. And then next up, we have the conic sections. Oh, Lord. All right. In this, there are many shapes and lines to be made, but they all derive from these four equations for the circle, ellipse, parabola, and hyperbola. As we can see, the circles need to equal 1 to be completed. And for the parabola here, you need to have equal to or greater than or less than on each side of your number, basically, or variable, in order for it to be complete. And then for the third one, we have derivatives and antiderivatives. And derivative is the slope of the tangent line. And as you can see, there's the equation off to the right. And for antiderivatives, it's basically what the derivative was before you got the derivative from it. And basically the equation is there off to the right. And then down here on the left, we have the example of a derivative, which is 2x to the third, and ends up changing to 6x to 6x squared. Sorry. And then the example on the right is a antiderivative, which is basically 6x squared going to 2x cubed. And then lastly here we have integrals, which is the area of a region on a graph. To most accurately find the area, we split the graph into sections using triangles, squares, and kind of many other shapes. The values on the integral symbolize from where to where is being evaluated on the x-axis, or that's the integral symbol that does that. A rectangle has a different area equation than a triangle, though. It has a base times height equation, and for a triangle, it's a base times height divided by 2. And then once you want to find the region of the whole line, you add those two areas together to find the whole. And thank you. That's all.